Okay guys, today we have the volume of prisms and cylinders. So this is taking the area into one more dimension, okay? And volume along with area is all about equations and formulas per se. So here's the formula that we have for a prism. A prism really is any kind of box or triangular prism is this one here because it has triangles at each end. All right. So the thing you got to be careful with though is a lot of people like to think that this big B stands for the base. Well, it's a capital B because it is different than a little lowercase b. All right, in this formula, that big B stands for the area of the base, okay, or area of that triangle or area of that rectangle. All right, at the bottom of that figure on the right. All right. So when you use these formulas, you have to plug in the formula for the area of whatever kind of prism you're talking about. Okay. In this case, it's a triangular prism. So I have to plug in right there the formula for the area of a triangle. All right. If I'm going to talk about this guy over here, I have to plug in right there the formula for the area of a rectangle. Okay, so this formula can take two different forms. It can take this form, 1/2 base times height, okay, times the height of the whole figure. Okay, so here we're talking about the dimensions of the base of this prism right here. So we could be talking about that lowercase b could be along there, all right? And then the height of that triangle along the bottom is this lowercase h right here, okay? This h over here, we're talking about the height of the whole prism. Okay, so it's a little confusing because we've got two different h's here, but this one in here is really the height along the base, and this one is the height of the whole figure. Like the way I try to think of it as I'm taking the area of just that little slice down there, and then that's this part right here, and then I'm pushing it through this whole height. That's what this height is for. Okay, so if I were going to be taking the area of this guy, I would be taking length times width. That's the area that takes the place of the big uppercase B over here. That is the area down here. So again, I'm taking the area of the rectangle down here, length times width, and I'm going to push it through the height right here. Okay, so this height is referring to this dimension right there. Okay, so this one formula, even though it's one formula for a prism, it can take on these two different forms here, depending on what kind of shape we're looking at. All right, so let's do this example. This is example one, and we've got volume of this prism below. This is a triangular prism because the ends are triangles. Okay, so I would be using this formula right here, and as with any other formula, you're just going to start with what it is. So I've got 1/2 base times height, and I've got my big height, okay, that would be this 20 right here. All right, so I'm just going to plug in everything that they give me. The half doesn't do anything, it stays the same. And the base here is talking about the base of this triangle. Okay, now because this is a right triangle, it really doesn't matter which one I use for the base and which one I use for the height. Because it's situated the way it is, the way it looks like, I'm going to use 12 for the base here. Okay, and the height of that triangle is 5. Alrighty, and then the height for this h is the height of the whole figure, so it's that 20 right there. All right, so the whole problem, just plug everything in. It comes down to multiplying all these together, and it really doesn't matter which order you multiply them, it's being all multiplied together anyway. So 5 times 20 is 100. If I take half of that, I get 50, and I'm going to make sure I get this right here. I want to take 50 times 12, and I get 600. Yeah, just wanted to make sure there, so get rid of that. All right, and make sure you got your units in there. Because you're working in a volume, now just a distance would be in inches. If I were taking the area right here, it'd be inches squared, but since I'm in a volume, I've used 3 dimensions, so it is inches cubed. Okay, so whenever you have a volume, you are definitely in inches cubed. All right, so there's your first example. Again, it's going to be about using these 2 formulas. Okay, so let me turn this one off and turn on example 2 here. And here we have a little different form of this formula. Okay, you notice it looks the same right here. The volume, oops, I gotta turn that on, hold on. This volume right here is the same formula as the other one, but again, with this big B, they're saying that this is the area of the base of this cylinder. Now, a cylinder is just like a soup can or a pop can, okay? And it has a base that is a circle, all right? And if you remember from before, the area of a circle is pi r squared, okay? So if I take this general formula that they have over here that I have from before, and I say, well, this big B stands for the area of the base, I plug this formula, which is the area of the base, which is a circle, into right there. Okay, so when I'm dealing with a cylinder, this formula takes this form, pi r squared. Okay, and again, this is just the radius of the base, because it's a circle, and times the height. So again, it's kind of like the other one. I'm imagining I'm taking the area of the base, and I'm pushing it through this height right here. So I'm taking the area of the base, and I'm pushing it through. I'm multiplying by that height. So to do example 2, I've got a cylinder here, and I'm going to just use this formula and plug in what they give me. They have find the capacity of the recycling bin shown, and to the nearest whole number. And so that's going to mean I'm going to round. So I am going to just plug in a 3.14 for the pi, and that really is a 4. I'll take it out of there and make it look a little better here. All right, and bam, that's a little better. And radius is, oh, that radius, look at that, that's a diameter. Okay, that is a diameter. I don't want to plug that 20 in there. I want to take half of that diameter, and I'm just going to square that. And then the height of the whole thing is 32 inches, so I plug that in there. All right. So again, I need to get my calculator up here. So 3.14, and I'm going to multiply by 10 squared. That's 100, and I'm going to multiply by 32, and I get the volume is a really big number. What was that? 10,048. Okay, so the thing you gotta be careful with here, though, is they throw a little curveball in here. This is all in inches cubed, all right, and they want to know how much you can fill this cylinder for, or with any kind of liquid, and they say use the fact that 1 inch cubed is approximately, that's what this little symbol, approximately 0.004 gallons. Okay, so I'm going to take, this is why they said round to the nearest whole number, because this number, I'm going to take that, and I'm going to convert this to gallons. All right, and knowing this fact right here, 1 cubic inch, or 1 inch cubed, is approximately 0.004. That means I can just multiply this by 0.004, and I get approximately how many gallons that I'm going to have. So I'm going to take that number, and I'm just going to multiply by 0.004 here, and that's 40.192. So if I round it to the nearest whole number, that's going to be 40. All right, so the volume equals 40 gallons. Okay, so there's example 2, and I'm going to put the checkpoint problems up here in a minute, and you can take your time here to pause it and do those checkpoint problems, and then unpause it and see if you're right. Okay, guys, here's the checkpoint problems. Let me just point out a couple things. Notice I'm starting every time with the general formula with that big uppercase B, and then I replace it with the area of the base, which in this case is length times width because it's a rectangle. And I do the same thing over here. Start with that general formula, and then I replace that big uppercase B with pi r squared, which is how you find the area of a circle, which is the base of this. So plugged in all the numbers here. Also notice I've got feet cubed and meters cubed there because we're finding a volume. So next up, let me turn this off and let me turn on the third example. I'm going to switch over to this green color here. So here we have not just a regular cylinder or a regular rectangular prism, but I've got kind of like a combination of the two. So the solid shown is composed of a rectangular prism. So right here is your rectangular prism, and I'm going to highlight it right here. There's your rectangular prism. And then we've got kind of like, oh, I can really draw straight there, can't I? Kind of on the edges, I've got a cylinder that's been cut in half and slapped onto each end. Okay, so to do this kind of problem, what you're going to have to do is just two parts and then add them together. So we've got, here's your general formula, and here's your general formula again. So I'm going to do the prism over here. Okay, I'll just put the word prism up here. And I'm going to do the cylinder over here. Okay, and so I'm going to change the formula. This is a rectangular prism, so I'm going to take length times width and times the height. Okay, and over here I'm just going to change the formula. This is a cylinder, so it's going to be pi r squared times the height. Okay, let me fix that. This funny thing over here, that's supposed to be an L. Notice when I draw this though, this is kind of like weird. It's not weird. I make my L's like that because if you make them like this, they look like a 1. Okay? So just use a little common sense here. That's a cursive L. You notice a lot of times we'll make the X like that. You know, we'll put the little curly part on it so it doesn't look like a plus sign. We'll make T's like that so it doesn't look like a plus sign or what have you. So whenever you're using an L in an equation, you want to use it like that. So anyway, here we go. Plug in the numbers. Let's see, for the rectangular prism here, we have it's 4 this way and 6 this way, and it would have the same height as this cylinder here, so it's 3. So I'm just going to plug in 4 times 6, and then a 3 out here. And if I do the math real quick, 24 times 3, let me check myself here, 24 times 3 is 72. Okay, so that's going to be a 72. And we are in meters cubed. And then this one over here, again, plug in the numbers. We're going to plug in a 3.14, and the radius is how big? This is the tough one. The radius, they don't give it to me. They give me this distance right here. That's the diameter of what would be this cylinder, or this half of a cylinder. Of course, I want the volume of the whole thing, so it's going to be this half of a cylinder, which is going to have the same dimensions. So this is actually the diameter, so I'm going to plug in 2 for the radius. I just cut the diameter in half, and the height of this thing is 3. So I plug all those in, and let's do a little quick math here. 3.14 times 2. Oh, I've got to square that, so I'm going to times by 2 again, and then I'm going to multiply by 3, and I get 37 point, what was that? 37.68. Okay, and this is supposed to be squared over here. Put the little squared in there. All right, so that is again meters cubed. So the volume of the whole thing, I just need to add these two together, 37.68, and I'm going to add 72. So I get 6, 8, bring that down, 9, and that's 100. But they did say to round to the nearest cubic centimeter, so this 6 right here tells me round that bad boy up to 110, and it's meters cubed. All right, so there you go. The work that you do in class is going to be very similar to these. The only difference is maybe we will give you the volume and the radius and ask you to solve for h. All right, but it's similar to others where you plug in everything they give you and you just do your algebra to figure out the one that you don't. So there you go. Oh, Kyle's online. Okay, go away, Kyle. So don't know who that is, but anyways, there it is. We'll see you tomorrow. Hope